Hi everybody, this is Mr. Murphy, and today I'm going to be taking you through arithmetic and geometric series as opposed to sequences, which you learned last class. So just quickly recapping from yesterday, you have your two formulas for your arithmetic sequence and your geometric sequence. Obviously, those are good to have. Write them on the top of the paper, a sheet next to you, whatever it may be. We're going to be referencing those as we go through today's lesson as well. So first thing is, what's the difference between a sequence and a series? So with the sequence, you were just figuring out what a particular term was, what number term it was in the sequence, all of that stuff. What a series is it's a sum of a particular number of terms in a sequence. So we're adding them all up. So because of the sum, we're going to use a S value for this. So if we're looking at, today we're going to focus on finite series, meaning that it's going to end at some certain point. Tomorrow you're going to look at, or next class, you're going to look at an infinite series, which has its own kind of set of rules for that. But for a finite series, if we say S sub 1, that's basically telling us what's the sum of the first term. So obviously that, you're not adding anything up, that's just 2. That's the first term within that sequence. If you said S sub 2, what that means is you're adding up the first two terms of our sequence. So our first two terms are 2 and 6, so S sub 2 would equal 8 for this. S sub 3, we just kind of keep going. It'd be 2 plus 6 plus 10. Right, we got 8 plus 10, we're at 18, and we can just kind of keep going with this. Obviously, we want to have formulas for this stuff. We don't want to always just be adding up, once we get to the first 3, it's fine. If we start adding up and getting to the, add up the first 20 terms, the first 50 terms, 100 terms, you want to have a formula for this as opposed to just sitting there and adding these things all together. Infinite series, it's the same thing. S sub 1 would be 1/2. S sub 2 is 1/2 plus 1/4. Obviously, this one gets a little bit trickier because you have fractions, so you'd have to make that 2/4 plus 1/4, so you got 3/4, and obviously you could continue on with that as well. We'll leave that. You can see kind of this dot, dot, dot here. That's indicating that this series goes on forever, or this sequence, I should say, goes on forever. You will learn special rules for that next class. So this class, we just want to focus on our finite series, meaning that these are going to end at some point. All right, so right off the bat, let's just address what the new formulas are. So kind of write them out here for you guys. We got S sub n equals n over 2 times parentheses t sub 1 plus t sub n. So all of these things, the meanings of all of them carry over from last class. N is the number of terms, t sub 1 is the first term, t sub n is the nth term, whatever one we're looking for is the actual term in that spot. S sub n is the sum of all of those. So that's our arithmetic. For geometric, again, obviously we're trying to find the sub, so S sub n, it's t sub 1 times 1 minus r to the n, all over 1 minus r. And while we're on this one, we want to put one little restriction for our r value. We want to say r cannot equal, and this is something that fresh off of our rational expressions unit, this should make plenty of sense to us. We can't have 0 in that denominator, so we have r cannot equal 1 because then we'd have 0 in the denominator. If you really think about it, if r equaled 1 for a geometric sequence, you're multiplying by that number, so it'll just be the same number over and over again, so it really kind of is irrelevant for this. All right, so I just kind of explained the S sub n, the nth partial sum of a series. That's what we're doing. We're adding up a particular number of terms. So example number 1, find the sum of the first 25 terms. So I'm just going to kind of underline that. That's important. Obviously, sum is telling us that we want to use series as opposed to sequence of the arithmetic series 11, 14, 17, etc. They're telling us this is arithmetic. Sometimes they won't tell us whether it's arithmetic or geometric, and we're going to have to figure that out. Okay, if we try and jump right into our series formula, right? If we say we got S sub n equals n over 2 times t sub 1 plus t sub n. If we plug in everything that we have with this, obviously the sum is what we're trying to find, right? So we don't have that value. We know that there's 25 terms. That's our n value. So we have 25 over 2. T sub 1 is 11 plus t sub n. This is where we get stuck, right? We don't know what that t sub n value is. So what we need to do with these, and this happens quite a bit, especially with our arithmetic, we're going to see this, we need to figure out what that t sub n value is. How do we do that? We need to find t sub n by using the formulas that you learned last class with our sequences, right? So if we want to find the 25th term, so it's t sub 25, this is the formula at the top of the page from yesterday. we'd say t sub 25 equals t sub 1, which in this case is 11 plus n minus 1, so 25 minus 1 times d. D in this case, if we're looking, right, d equals 3 we can see. So this would be all times 3 on the outside. We solve that out, right? Obviously we're doing the 24 times 3 first, and then we're adding 11 to that. We should get 83. That means that the 25th term, if this kept going and we got to the 25th term, that number in that spot would be an 83. All right, we're going to take this 83, plug it into our sum formula over here, right? And then we can solve this out. We can say sum of the first 25 terms. That whole thing you can just put right into the calculator, and you should get, I think it came out to 1,175. All right, so just to reiterate what that means, it means if we wrote out all 25 terms in this sequence, the first 25 terms, and then added all 25 of those things together, that's what the sum would come out to be. All right. Example 2 deals with geometric series. So we're saying first 10 terms, they're telling us this is geometric, right? So our R value, we can see to get from 2 to -6, R is going to equal -3. What you're going to find, the geometrics are actually easier with this, right? We got our geometric series. If we want some of the first 10 terms, what are we plugging in? We've got our first term, so 2 times 1 minus our R value, which is, and careful here, make sure that we're using parentheses for this because you're raising it to a power. So if you have a negative number, you need to make sure that that negative is in parentheses being raised to the n. So the n in this case, there's 10 of them that we're adding up, right? And then that's all over 1 minus, again, parentheses with the R. What makes the geometric ones nicer, why I was saying that they're easier to solve for, is because you don't necessarily need that 10th term. So we don't need to do what we did over here with this one. We can just plug right into the formula with this. We have enough stuff. That whole thing, as long as you're really careful, can go into the calculator. And I got negative 29,524. So obviously I plugged some of these in already on the calculator. While you guys are plugging these in, I would suggest maybe pause the video for a second just to make sure that you're getting the same thing, and then continue on from there. All right, let's try a couple more tricky ones. Example 3, given the sequence 14, 12, 10. So they're not telling us whether this is arithmetic or geometric. Hopefully it's easy enough to kind of determine. We're saying we're going down 2 by everything. So this is our common difference here is -2. They're telling us S sub n equals -54. So they're giving us the sum in this particular case, right? So if we I'm just going to rewrite our sum formula because I know we just flipped the page here. So we got n over 2, t sub 1 plus t sub n. So I'm choosing that formula because we know that this is, the first step of this was to determine what it is. So we know that this is arithmetic. That's why we're using this formula. If we try and plug things in, look what happens. We know the sum, so a little bit unique. We get -54 equals, we don't know how many terms there are. We know the sum of all of them. We don't know how many are being added up. We know t sub 1 is 14. If we don't know how many are being added up, we obviously don't know what the nth term in all of this would be. So the problem in this point is we still have 2 unknowns. When I say 2 unknowns, we have n and we have t sub n, right? If we just had one thing, or right, in math, if we just have an x value, we're able to solve for it. You got x's and y's, that makes it substantially more difficult. So what can we do? We have formulas where we can rewrite t sub n in terms of n. So I want to kind of go over here on the side and say, all right, our t sub n is going to equal, using our arithmetic sequence formula, it'd be 14 plus n minus 1 times our difference, which is -2. If we simplify this a little bit, we can say, all right, t sub n is going to be what? This is going to be 16 minus 2n, right? Because you distribute the -2 first through the n minus 1. That would become a +2, so that's where the 16 is coming from, minus 2n. So now we can take this value and we can substitute it into our second equation, right? 2 unknowns, we set up a little system, we substitute this in. So at this point, we have -54 equals n over 2 times, we would be at what? 14 plus 16 minus 2n. This is the value right here that we just substituted in. Now we got everything in as just an n value, and we're going to be able to continue on and solve out the problem. I'm going to simplify just what's in the parentheses real quick. So we would have what? We're at 30 minus 2n. At this point, you have two options. You can either multiply the 2 to the other side, but see how everything kind of goes in nice. 2 is going to go in nicely to both of those values. So I could say negative 54 equals, if we distribute through the n over 2, we're going to end up with 15n, and then that would be minus n squared, right? These are n values, but we're more familiar with seeing them as, if we had 15x minus x squared, hopefully everyone would be thinking we need to get everything to the same side and factor. I'm going to bring everything to the left just to make the n value positive. So n squared minus 15n minus 54 equals 0. Kind of running out of room here, but we would want to factor that. So we get n minus 18 and n plus 3 equals 0. So then we could say, all right, n equals 18 or n equals negative 3. Think about what our n is referencing. N is a number of terms. You can't have a negative number of terms, so we can cross out that negative 3, and we get an n value of 18. What that means, let's tie that all back together. That means that if you kept this sequence that we started with, the 14 plus 12 plus 10, that series, and you added up the first 18 terms of that sequence, the sum of all of that would come out to be a negative 54. Right? And it may be a little bit confusing because you're seeing a negative, but you should be able to see that with that difference of negative 2, pretty quickly you're going to start adding some negative numbers into this mix. That's where that's coming from. There was a lot within that. So obviously you're using both of the formulas that we've learned so far this unit. You had to use some substitution. If that problem made sense, you are in great shape for right now. That means that you're really understanding what we're doing, and you should be feeling pretty confident with your understanding of sequences and series up to this point. All right, let's take a look at one more here. So this is one, maybe try this one on your own if you're feeling confident before we get into our sigma notation. This is the last of kind of the practice problems before we get into that. So if you want, maybe pause the video, give this one a shot. If not, obviously I'm gonna continue forward with it just so that you guys can check your work. All right, determine the sum of the series. They're not telling us arithmetic or geometric. 5 to 35 and then 35 to 245. It should be very clear that this is not arithmetic. What are we doing to get to that number? We're multiplying by 7. So our R value is 7 in this case. Okay, so we're trying to determine the sum of the series. The problem with this is we don't know how many terms there are, right? So if we tried to jump right into our series formula, we need to know the number of terms for that, which we don't know yet. So this is an instance where we need to go back and use our sequence formula. All right, so we know what the nth term is. The nth term is that 4,000, or what do we got? 4,117,715 equals, it would be 5 times r to the n minus 1. All right, so this is using our sequence formula from last class. How are we going to solve this out? A little bit trickier. We got an exponent there. Any of our exponentials, hopefully remember that we need to isolate the exponential to start with. So we got to divide these both by 5. So I got, let's see, 823,543 equals 7 to the n minus 1. All right, really bringing a lot of what we've learned recently together on this problem. We have an exponent as our unknown, right? If we're trying to get that exponent down, we need to take the log of each side. So if we take the log of 823,543 equals, all in one step, I'm going to bring down the n minus 1 log 7, right? That's the reason we took the log of each side, because we can bring that down. Divide each side by log 7, right? Plug that all into the calculator. So if you do that, you get 7 equals n minus 1, add the 1, and n equals 8. So a lot of work with that just to get our number of terms. Now that we've gotten that, we can kind of come over here and figure out what our sum would be. So we want the sum of the first 8 terms. We're using our series formula for this. This is a geometric series. So we got t sub 1, right? So we got 5 times 1 minus r, so 1 minus our r value, which was where we at 7 to the, and I guess just to kind of be in the right mind frame, we'll put that in parentheses just so when it is negative we remember to do that. Raised to the n, which is 8, all over 1 minus r. That whole thing we should be able to put into the calculator, and we should ultimately get 4,804,000. All right, so those last two, definitely a little bit tricky. If you have questions, hopefully you can address those with your guys' classroom teachers. At this point, what I want to do is I want to look at what's called sigma notation. So at this point, you should be familiar with alpha, beta, theta, things like that. This is just more Greek lettering here. This is our sigma notation. That's our symbol for sigma there. Looks very scary at first, but we'll kind of go through what everything means. This is just a way to write out, kind of to not to use a pun here, but to sum up what's going on with our series. Okay, so a couple big things. The number that's on the bottom of our sigma here, this is like your starting point. I would say you're pretty much always going to start with number 1. This is saying how many terms do you want to add up, right? So you want to add up from the first term to the nth term. So that's your stopping point. So usually we're going to have a number on these. So like if we just kind of quickly look down at 1a below here, this is saying that you want to add up from the first term to the third term. So basically saying you want to add up the first 3 terms. We don't know what it's always going to be, so we put an n value there. The t sub k, this is just the particular equation for that sequence, right? So you kind of just simplify the sequence equation for that particular sequence, and that's what would go in that spot. What this all just means, it's a fancy way of saying you want to add up t sub 1 plus t sub 2 plus t sub 3, ... all the way until we get to t sub n. All right, that's our stopping point. I get that that's a little bit confusing at this point. Hopefully when we do a couple practice problems, this will all make sense. All right, so this is saying, if we look at 1a, this is telling us that we want to add up the first 3 terms, which I know by looking at the bottom is saying starting at term 1. And like I said, you're pretty much always going to be starting with the first term. Very rarely are you going to have a question where it says add up terms 10 through 15 in a particular sequence. It's usually always going to be, what's the sum of the first 10, the first 20, first 30, whatever it may be. This 2 plus 5k, that's our particular sequence for this. So if they're giving you that, one method is we can figure out, just by plugging into this, we can figure out what our first term is, right? So if we put in a k value of 1, if we say 2 plus 5 times 1, that gives us our first term. So we're essentially saying we want to do that, plus our second term would just be 2 plus 5 times 2, plus 2 plus 5 times 3. So this is basically saying, all right, here's our first term, which is that comes out to be a 7, plus we'd have 12 plus 17, right? We add all those things together, and this equals 36, all right? The sigma notation, all that did was kind of summed up what the problem was asking us. So it's using the sigma notation, these symbols, as opposed to writing out the entire problem in words. Let's look at another one here. We got 2 times 3 to the k minus 1. So again, I would say let's just plug in the actual numbers here. So if we want we're adding up the first 3 terms again. So 2 times, it would be what? 3 to the k minus 1. So 1 minus 1, so 3 to the 0. Plus 2 times 3 to it's the second term, so 2 minus 1, plus 2 times 3 squared. If we simplify all of these, 3 to the 0, so we just got, that's going to be just a 2, plus 2 times 3, so plus 6, plus 2 times 9, so plus 18. We add all of those up, and we get to 26. For part C, it should look very familiar to part B. The difference is that 2 is now pulled out in front of the sigma, right? So this is really saying we want 2 times the sum of all of what's inside. So this would be what? 3 to the 0, plus 3 to the first, plus 3 to the second. If we simplify that, we get, kind of just do it down below here, we get 2 times, we'd have just 1 plus 3 plus 9, right? We end up with, again, that is going to be 26 again. What do we notice? We notice that it doesn't really matter if the 2 is out in front or attached, it is going to be the same thing. So just something to note, it doesn't really matter on that. You're going to get the same answer with that. All right, that's if you're given the actual sequence like that. If they give you some a couple of numbers within a sequence and they tell you they want you to write it in sigma notation, that's where you really have to understand it. So let's try this one out together. Maybe we'll try part A and part B. You guys can try on your own there. All right, sum of the first 5, 9 plus 5 plus 1 plus -3. So right away, we should be able to kind of figure out what are we dealing with. So this is a D value of -4, common difference of -4. That's telling us it's arithmetic. So when I'm trying to write my sigma notation, right, that's our sigma symbol. We're saying we want to start with the first term. That goes on the bottom. This right here is saying sum of the first 5. So that means that the number that's going up top is a 5, right? The value that goes in this spot here, right? That kind of missing place that we have right there. That's our T sub n equation. So we need to write out what our T sub n equation is for this. So T sub n is going to equal what? 9 plus n minus 1 times our D value, which is -4. So notice that I'm leaving the n value in. We want n to stay in the equation. We don't want to put, even though we want the sum of the first 5, we're not trying to find that fifth term. We're just trying to find a general equation for T sub n. So if we simplify this, we get T sub n equals, this would end up, if we distribute through and combine like terms, we're going to get what? -4n plus 13. This is the value that's going to go right here. So -4n plus 13. This is the way we would write our sigma notation for this problem. It doesn't answer any questions. That's what's kind of frustrating about this. It just sums up really what the whole problem is. It didn't actually answer for us what the sum of the first 5 terms were. If we did that, if you kind of think about it, if we look back up here, we had first term, second term, third, fourth. Our fifth term, if we continue on with this, is just going to be a -7, right? So if we now plug that into our sum formula that we learned today, our series, we got n over 2 times 9 plus -7. We simplify all that, and we get a 5. All right. What I'd suggest, everyone try and do part B on your own. Let's see how you do with it. Obviously, first step is figuring out whether it's arithmetic or geometric, but then challenge yourself, see how you do with the rewriting it in sigma notation. Obviously, there's going to be probably a key posted, so you should be able to check your work with that. There'll probably be an exit ticket for you guys to complete, along with, if there's any other practice problems that your classroom teacher assigns to you guys. Obviously, good luck with those. Hopefully everything made sense today, and talk to everybody soon.